Many thanks Alireza and good day everyone. I will now continue with the introduction to the Detectium Company, explanation of the problem that we are addressing, and our technical solution enabled by digital twinning. Fire is an increasingly important risk factor in today's world. The fire occurs not only in the forests and residential houses, but also in other contexts such as the ships and industrial facilities. According to the Resilink Annual Supply Chain Risk Report, in the year 2020, factory fires for the second year in a row are identified as the leading cause of global supply chain disruption. According to the National Fire Protection Association report, approximately 38,000 industrial fires are annually reported to the fire departments across the United States. These fires result in an average annual damage of $1.2 billion and unfortunately a death toll of 16 with many more injuries. These facts illustrate the importance of fire risk mitigation measures in industrial facilities. Among the things that can be improved in the fire risk mitigation efforts is the fire detection process itself. The majority of the current fire detection systems that are used by the industrial companies rely upon smoke detectors and thermal cameras, also known as infrared sensors. The biggest shortcoming of these systems is related to the fire detection speed. For instance, smoke detector won't detect the fire until there is enough smoke in the environment to reach the sensor, and by then it might be already quite late to effectively extinguish the fire and prevent the consequent damages. The other issue with the current solutions is related to the lack of data analytics, as the sensor output cannot be extracted by other systems, and therefore an accurate fire size measurement and fire localization is not possible. Detectium's mission is to address these issues by taking advantage of the digital twinning concept. We utilize a novel UV sensor with extremely high sensitivity and combine that with infrared and visible light sensors to enable ultra-fast fire detection, localization, and flame intensity evaluation. In this way, we provide a superior tool for fire risk mitigation in the industrial facilities. Our digital twin solution consists of three major components: the advanced sensor package, which is customizable according to the client's needs; a 3D visualization component that allows intuitive and accurate presentation of the current status and future prognostics; and a data analytics component that relies on the collected historical data to create a dashboard for the client and to provide a fire hazard map for the factory. Now I will discuss our sensor system. The novel UV sensor used in our solution is developed by our partner Fenoaro. They have extensive experience with the development of X-ray detectors, and they adapted their proprietary technology to create a UV sensor which is among the most sensitive in the world. This allows our solution to detect the fire earlier than the current solutions on the market and at farther distances. Our sensor package makes use of Raspberry Pi 4 to communicate with the cloud-based Backbone API and has the presented layout of the UV, IR, visible light, and motion sensors. 3D visualization is the second component of our digital twin. We can create the 3D visualization of any environment using the floor plan and the pictures illustrating the arrangement of the equipment and the furniture in the environment. In the first example, a floor plan and in-person observations were used to create the 3D model. This 3D model is related to an office space. In the second example, the floor plan and images were used to create the 3D model. We use Unity software for the visualization purpose, which enables the integration of the real-time data to the 3D model and the implementation of the WebGL. The third and final component of our digital twin is data analytics and hazard mapping. The data collected by the sensors is sent to the back-end API. This data is then stored, analyzed, and presented to the client in a customizable dashboard. One function of the data analytics is to use the historical data to present a fire hazard map to the customer. Now let's observe how the digital twin works in a simple test. The purpose of this test is to illustrate the capability of our digital twin in detecting, localizing, and identifying the flame size in real time. We used the prototype of our sensor package to detect a candle flame in an office space. The video on the right bottom corner of the screen is the real-time screen capture of the digital twin 3D visualization. In case that the fire is evaluated as dangerous by our digital twin, a notification is sent to the client and the location of the fire in the facility is pinpointed in the 3D model. To conclude this presentation, I summarize the value proposition of our digital twin solution for the industrial companies. Our digital twin enables the ultra-early detection of fires in industrial facilities. Moreover, analytics algorithms of our digital twin can determine the fire intensity and also the exact flame location. These pieces of information can prove to be invaluable for fire extinguishment efforts. Thank you very much for your attention.